Point is all the above three layers, including session layers, are integrated in a single layer in the TCP/IP model. So those three layers, what are the three layers? Integrated three layers means application layer, presentation layer, and session layers integrated in an application layer in the TCP model. So in the TCP models, those three layers, application, session, and presentations, are clubbed together in the application layer. Implementation of three layers is done by the network application itself. They are also known as upper layer or software layer. So these three layers maintained by the transport, including transport, maintained by the hardware. So this is the things under this sender and receiver in the application layer. Let's move on to the next point, presentation layer. Presentation layer is also called the transport layers. Presentations also called the transport layer. The data from the application layer is extracted or the manipulated as per the required format to transmit over the network. So the data from the application layer is extracted here and manipulated as per the required format. Okay, as per the required format to transmit over the network. So data from the application layer is sent to the application presentation layer and manipulated in the required format. So it's manipulated in the required format, like if you type any message, or if you upload the photo in the Instagram or Facebook, or if you add a video in your WhatsApp or attach some documents. So the data format is very different with the text documents and video documents. Okay, so this is done by the presentation layer. It represents in a different type of data format to transmit over the network. So formatting of data is done in the presentation layers, which is received from the application layer, upper layer. The function of the presentation layer are the translations. Example, ASCII and EBCDIC. ASCII is the American Standard Code for Information Interchange, and EBCDIC is the Extended Binary Code Decimal Interchange. Interchange code, EBCDIC. All those things are the interchange code from our standard alphabet alphanumericals into the binary informations. And the next point is the encryption and decryptions. Encryptions is the transform into the different types of formats which cannot be seen by the plain text, and decryption is to revert it back to the original plain text. So this is done by the presentation layer, encryption and decryptions. The encrypted data is also known as ciphertext. What is ciphertext? Ciphertext is the decrypted data. So it needed to decrypt it back. This encrypted ciphertext is known as the plain text. So a key value is used for encryptions as well as decryptions. So in this we need to have a public key and a private key for this encryption. And also it's done the compression also. In this presentations, it's compressed the data which is received from the application layer. So the data is might be very big if it's converted into form. So it's needed to compress like a zip file or RAR file. So compressions means reduce the number of bits that need to be transmitted over the network. So suppose if you capture the photo in your mobile phone, then it's added into the application layers in your application, say suppose WhatsApp, then it's needed to send out, then it goes to the presentation layers, then this photo is too big, then it's needed to convert into the JPEG or maybe different types of format. So these are the compressions. And let's go to the topmost layer, layer number 7. At the topmost, very top of the OSI reference model layer stacks, we found that the application layer, which is implemented by the network applications. These applications produce the data which has to be transmitted over the network. This layer also serves as the window of the application services to allow the network or for displaying receive information of the users. So this top layer is the window applications of the services. We can say at the top layers we have different types of applications to receive the image, video, or any other application to display to the users, and also to transfer to the network. Okay, to send down to the below layers. Example is the browser, Skype, all those things are the network layer, application layer. Application layers also called desktop layers. Then function of the application layer is the network virtual terminal, this NVT virtual terminal, terminal emulator, and then the FTAM, file transfer access and management, and the email services, directory services. So all are the applications layer functions. OSI models act as a reference model. So here this point is very important. OSI act as a reference model. This is for reference. If we say reference is not actually implemented, we have to refer this point. And also not implemented in the internet because it's late inventions. So current model being used in the TCP model. So TCP IP is the current model based on this OSI. Okay. Let's move on to the TCP IP. TCP IP models are developed prior to the OSI reference model. The TCP model is not exactly similar to the OSI. So it's very clear. TCP IP model consists of 5 layers: application layer, transport layer, network layer, data link layer, and physical layer. So it's having 5 layers in the TCP, but in the OSI reference models we have 7 layers. First, our layer provide physical subnet, network interface, interconnection, and transport function, and correspond to the first 4 layers of the OSI. And those 4 layers are represented in the TCP models by a single layer called application layer. So that's clear. TCP IP is hierarchical hierarchical protocol made up of interactive modules, and each of them provides specific functionality. Each hierarchy means that each upper protocol is provided by 2 or more layers. So the function of this TCP layer is this application layer, presentation layer, transport layer, network layer, and data link layer. So in the TCP layers, all these 3 are converted into the application layer, transport layer, and network layer, data link layer. Network layer is called internet layer, and this is the network layer. This is the internet layer, this is the network layer. All these 2 are combined into this physical layers. Okay, so that comes under these things: application layer, session layer, all these things come under same layer. Okay. So network access layer, this is the network layer in the lower case of TCP IP, and network layer is a combination of the physical layer and data link layer. Okay, the last one. Okay, this one is the network layer. It's defined how the data process to be sent physically to the network. So internet layer step by step. It's explained again, internet layer. I already explained all these things in the OSI reference model. I'm not going through again those things. Okay, let's jump over to the ARP, address resolution protocol. What is the ARP stand for? ARP stand for address resolution protocol. ARP is a network layer protocols which is used to find the physical address from the IP. Okay, physical address means what? Physical address means MAC address. So you know the IP address of the computer, but you don't know the MAC address. But you are working in the data link layer. So for transferring the data in the data link layer, we need to have the MAC address. So we need to know the MAC address. You know the IP address of the computer, particular computers. Then ARP send the request. I am having the IP address of this, but I don't know the IP address or MAC address of this particular IP. So it send out the request. Is there anyone to send me the corresponding MAC address of this particular IP? Then it send out the request. Then computers which is in the same networks receive these informations. Then it's compared with the IP address. Then one computer match the IP address, then it send it back to the request computer. Okay, so this is the working of the ARP. Two terms are mainly associated with the ARP protocol is that ARP request and ARP reply. So ARP request is sent out, this is in the broadcast, and ARP reply, which is sent it back by the computers, this is called unicast. Okay, it's sent back in a single point. Okay. ICMP, Internet Control Message Protocol, this is very important. So ICMP is a mechanism used by the host or routers to send notifications regarding that datagram problem back to the senders. So it send it back the informations. This is apart from this other protocol. This is for the network management. Okay, Internet Control Message Protocol. The datagram travel over the router to the router until it reaches to the destinations. If a router is unable to route the data because of some unusual conditions such as the disabled linked device is on fire or network congestions. So there are some unforeseen condition in the network devices, maybe in the routers. So this is the unusual conditions like link missing or the device is on fire or network conditions. Then the ICMP protocol is used to inform the senders that datagram is undeliverable. So this ICMP protocols inform that the sender, okay, the source, inform the source that datagram is undeliverable. And ICMP protocols mainly used two terms, ICMP test and ICMP reply. So ICMP test is used to test whether the destination is reachable or not. So let's see here. Command prompt ping 192.168.0.22. Here it send out the ICMP packet to this number, but here it's timeout. So not ICMP cannot reach to this. This is called ICMP test. Okay. Destination unreachable. Destination is reachable or unreachable if I'm shut down my Wi-Fi. Say suppose right now I cannot shut down my Wi-Fi. If I'm shut down my Wi-Fi, then the online is disconnected. Will be disconnected. So this is the thing in this ICMP test. First is check whether the destination is reachable or not reachable. Okay. Next one is this ICMP reply. ICMP reply is used to check whether the destination device is reachable or not. Okay. Reply is reply it back. Okay, by the destinations. Reachable device is reachable or not. Okay, the core responsibility of ICMP is to report the problems, not correct them. Not correct them. The responsibility for the connections lies with the senders. Okay, whether there is a connection or not, error or not, but it cannot correct it. This one, ICMP can send a message only to the source, but not intermediate routers, because the IP datagram carries the address of the source and destinations, but not the routers that it is passed through. So ICMP is working in this, and then the transport layers, no need to explain, but user datagram protocol is under the transport layer. So transport layers is provided connectionless. Connectionless means not secure. Okay, end-to-end delivery of the transmission. This end-to-end delivery of the transmission, but this is not secure. Okay, connectionless. It is unreliable protocols, and it discovered the error but not specify the error. So it can knows the error but it cannot correct it. Okay, send out, simply send out the data. Does not mind about whether it's reached the destinations without error or without dropping the signals. User datagram protocols discover the errors, and ICMP protocols report the error. So it discovered the error and ICMP reported back to the sender. So these are the combination of this UDP and ICMP to the senders, and the user datagrams has been damaged. So that if there are some problem in the damage or lost. Okay, the datagram. UDP consists of the following fields: source port, destination port. So it's very clear. Transport layer, assign the port. It's very clear. Source port, destination port, total length, checksum. Checksum is for error correction and error detections, but it is connectionless. Checksum means only the datagram. Okay, only datagram is checksum in this field, not the transmissions. UDP does not specify which packet is lost. UDP contains any checksums. It does not contain any ID of the datagram. Okay. So TCP transmission in this TCP IP transmission control protocol in the TCP is the full support layer of these applications. It creates virtual circuit between the sender and receivers. It is an active for the duration of the transmission. TCP is a reliable protocols, and it detects the error and transmit the damaged frames. Therefore, it ensures all the segments must be received, and for the transmission, it's considered to be complete. And a virtual circuit is discarded. So, if at the sending end, transmission divides the whole message in a smaller unit known as segment, and each segment contains a sequence numbers which is required to reordering the frame to form an original message. At the receiving end, TCP collect all the segments and reordered them based on the sequence number. That's also very clear in the OSI. I already explained. Application layer also very clear. All those things are there. Let me explain this data and signal. Data is the content of the data communications. We can define data as a raw collection of zeros and ones. Data is the raw collection of these informations, being the result of converting the data into a meaningful format. In short, data can be interpreted, managed, or converted by software instructions so that it becomes an information. So only zeros and one. Alternative zeros and one does not mean anything, but we have to process it by the software with a formal instructions. Then it's become the informations. So its transmissions have to be encoded in a language that can be transmitted. Signals are the electric or electromagnetic impulse used to encode the transmission. So we have a data, okay, zeros and one. So we cannot simply transmit this 0 and 1 meaningful instructions or the informations. We cannot simply throw it inside the transmission. So to carry those things, we need the signal. Okay. What is the signals? Maybe different types of signals, electrical signal or electromagnetic, or maybe a light signals. So these signals carry those data that we have to transform into the electric signals or magnetic pulse, or maybe in the light format, or maybe in the radio format if we transmit. Okay, so these are the signals. Signals carry the data. Okay, data is the organized organized informations. Okay, organized informations. Data is then transmitted through the same mediums such as cable or the air. The receiving node then receives that conversions and turns the electrical pulse or the wave back to this zeros and one, the representation of the original signal. So this is the example of data and signal. Okay, data and signals. Data is the organized informations, organized binary informations. So this organized binary informations is sent to a signals. Okay, signals means that the electrical or electromagnetics or maybe the radio wave or light pulse. This carries the digital signals, and the receiving end is converted back into the original data. Okay, then what is the analog and digital signals? Analog and digital signals are different. Analog and digital signals. Analog waves are continuous and infinite scope. So down below we have a signals here, analogs. This is infinite, okay, continuous. But digital signal is discrete. 0 start to 5, down to 0, up down, 0 5 0 5. Okay, so these are the things in this digital and analog signals. So all sound waves are analog. So these are the analog signals, or temperature, thermal, all those things are in a analog form. Vibration also. But digital is the discrete signals. Okay, telephone line also carrying this waveforms in the analog signal. Telephone line also analog carrier. Okay, our brains where the data is interpreted using the sound wave also. This is called analog. Digitals are quite different from the analog signal. Digital signals are not continuous or infinite. So rather they are voltage or light pulse converted into analog or digital data is specific zeros and one. The pulse are easily transmitted and regenerated through the network. So it's very simple as compared to the analog. This is discrete voltage. Only two states are there, zeros and one. Okay. Like analog ending concept, digital signals also have to be encoded with a language or control that both the sending and receiving pair node can be interpreted. Okay, so these are the things, the analog and the digital signals. Let's move on to the transmission impairment. Transmission impairment. This transmission impairments we have three types. Okay, in the communications, analog signal travel to a transmission media, which tend to deteriorate the quality of the analog signals, which means that the signals of the beginning of the mediums is not the same as the signal of the end of the medium. So in between these, there's chance of errors or the alteration of the signals. So it cannot be same at the receiving end. This imperfection cause signal impairment. So under this signal impairment, we have attenuation, distortion, and noise. What is attenuation? Attenuation is the loss of energy, loss of power or energy. So for transmitting the data, we need the power. So electrical, electromagnetic, or the waveform or anything, so we need the power to transmit the data. So if the power strength is go down, then it loses the signals. Okay, the strength of the signal decrease with increasing distance, which cause loss of energy in overcoming resistance of the medium. This is known as attenuation of signals. So it's very clear that if we lose the power, then it loses the signals. Amplifiers are used to amplify the attenuation signals, which give the original signal back and compensate to this loss. So to revert it back to the original signals, we need to amplify the power. Okay, we need to amplify the power. So original signal attenuated and amplified back again, then it will get the original signal. So attenuated is measured. Attenuation is measured in terms of dB, decibel. So it measures the relative strength of two signals or one signals at two different points. So it's measured the relative strength of two signal or one signal at two different points. Then this measured in terms of the decibels. Okay. Okay. Then distortions. Okay, distortions we'll continue with tomorrow. That's all for today. We'll stop here up to this attenuations, then we'll continue to distortions. Then we almost completed the first unit.